Good day, good day, good day. How are you all doing? Thank you for streaming and tuning with us. Welcome to Yebo Tutor live stream help on this marvelous day, on this marvelous Thursday. I'm streaming live from CBC in South Campus. Today we'll be doing statistics. Bear in mind that we are preparing each other for the trial exams which are about to start. So if it's your first time to tune in, please do subscribe, like, and share our page, our channel, so that we can reach out to many people as we can, so that we can equip each other in the preparation for our trial exams. So today, as I said, we'll be doing statistics. So statistics is a paper. It's a paper one. It's paper two, sorry. It's the question one for paper two. As you can see, this is 20 basic education. National Senior Certificate, which was from last year's paper. So we'll be doing statistics today. So statistics contain 20 marks in your paper 2 exam, or in your paper 2 exam, yes. So you must be able to know that 20 marks from statistics, you must just collect them, because bear in mind in our paper 2 we said that we have 4 topics. We have statistics 20 marks, we have analytical geometry 40 marks, then we have trigonometry also 40 marks, that's 100 marks. Then the last big boss is 50 marks, which is Euclidean geometry. So today we'll be doing statistics, so it won't be a long session. It's going to be a short session, short and precise. So if you have any question, please do ask us on the comment section. And also, if you have any question, please do ask. You can join the WhatsApp group in the description of this video, so that you can actually ask us your questions on our WhatsApp channel. Let's now get down to the business of the day. So before we go to this question paper, I would really love us to focus or to look at this sort of like a small overview, the terminology which is used under statistics. So what is important is to understand that when you are doing statistics, you just have to understand the English because the English, which is the terminology which I wanted to get used to today, is what is important. For instance, you must understand, what do they mean when they say the model class? What do they mean when they say the mean class? What do they mean when they speak of those kind of terms? So what is important is to understand those terminology. For instance, they are talking about the standard deviation of the data. They are also talking about the mean number of loaves. They're also talking about the number of days. So these are basic things. You must be able to understand the terminology first before you try to attempt to do a question. So now it's going to be a short session, but let me start with an overview. As you can see that we have the grade 11 and the grade 12 statistics. When you're writing your paper 2, question 1, the first 10 marks, it's usually on grade 11, then the other 10 marks is always from grade 12 work. So we're going to try to explain as much as we can. So now let's get to the overview, which we want us to start with. So on the overview, I want us to start on the overview right now. Okay, let's start with the overview. Let's start with the overview. Here we are. There we go. Okay, great. So now, on our overview now, what is important is to understand few things, okay? So I'm just going to do the overview for grade 12 work, because grade 12 work was it's what is so a bit important. So now to say that today we'll be talking about statistics, okay? So this is the topic for today. We are talking about statistics. So when we're talking about the statistics today, I want us to focus. Right. So on the statistics, what is important, A, is to understand the term by variety data. So this is usually in grade 11, it's data handling. So now we want to talk about the data now. So we're saying that we have the term by variety data. So what does that mean? This is the data that involves the study of two variables at the same time. Okay, so this is the data that involves, so it involves the study of variables at the same same time. So bivariate data is this is the data that involves the study of variables at the same time. Okay, great. Examples so that we can have it. So the examples is that maybe we are talking about the speed of a car, and maybe we can say the speed of a car, and maybe we can say the fuel consumption. Okay, great. The speed of a car and the fuel consumption. So you can actually see that we highlighted the fact that they are bivariate data is the data that involves the study of variables at the same type. So you can actually say that these are the variables at the same type, in the sense that we can also say that this is the speed of a car and the fuel consumption of also a car. So they are of the same type. Now there's other terminology which is important, which you must understand, is what we call the correlation. Okay, so we have the term correlation. So what is correlation? So you must understand that correlation, it is the relationship between two variables. Okay, let me just write it down. It is the relationship between two variables. It is the relationship between two variables. Okay, comma, the independent. We have the independent variable x and the dependent variable y. I hope you all understand the terminology behind this. Let me just highlight this part because it's quite important. That is an independent and the dependent variable. So we're saying that a correlation, it is the relationship between the two variables, the independent variable x and the dependent variable y. So bear in mind that when we are just plotting a simple graph, we know that we plot it according to, we have the x and the y, x and the y axis. So if this is a straight line according to Ohm's law, we know that Ohm's law, it says that all those things, they're in a straight line when we are looking at the voltage and the current. Okay, so now looking at this is the straight line. So we can actually see that in order for there to be an increase on the y-axis, the x must also increase. So we can actually see that x is an independent variable. Why? Because if there is no an independent variable, there won't be a dependent variable. So in other words, we are saying that when you are talking about the terminology of correlation, you must understand that it is the relationship between two variables. Which are these two variables? The x and the y. But these two variables now, they are termed, or they are called, the other one is called the independent variable, the other one is called the dependent variable. So the dependent variable, which is the y, is depending on the x. So the x, if it changes, the also y will also change. If x remain constant, also y will remain constant. So this is important to understand, that on the correlation, we are looking at the relationship between two variables, the independent and the dependent variable, which are illustrated by x and y. Why am I using spending much time on explaining that part? Because on grade 12 statistics, what is important is to understand this part of correlation. Okay, now what is also important is to understand that after we are done with correlation, we must understand the terminology that we have what we call the correlation coefficient, and it is illustrated by R. This is important. The correlation is so important. Okay, so how is this important? This is important because you must understand that the correlation, it measures the strength of the correlation. Okay, so the correlation coefficient is there to measure. Let's do this. The correlation coefficient is there to measure the strength of the correlation. Okay, So we are saying that the correlation is so important. The correlation efficient is so essential. It's so important because it measures the strength of the correlation. So what is also important is to understand that as it measures the strength of the correlation, the values of R. So we say the correlation efficient is illustrated by the letter R. This is the letter which is illustrating the coefficient correlation coefficient. So this letter R now, it's so important because now you must understand that this letter R only lies between -1 and 1. So next point on correlation efficient, you must understand that the coefficient, let me write it in different color, the correlation coefficient let me just R in brackets. Okay, great. Is between -1 and +1. So if your correlation value which you have calculated is above 1 or above -1, then definitely your answer is wrong. Why? Because the correlation coefficient, which is illustrated by the letter R, must be between -1 and 1. So there is actually a correlation table which is so important. So the correlation table is important in the sense that I hope I'll try to attach this also so that you can get it, because you must understand that when R is equal to 1, it is a perfect positive correlation. They will ask you that based on the value of R which we have, what does this mean, or what is the description of the correlation? So you must understand that if it's your R is equivalent to 1, this is a perfect positive correlation. Then if your R is between 0.8 to 0.99, you must understand that is a very strong positive correlation. And if it's from 0.6 to 0.79, you must understand that it's just a strong positive correlation. Then after that, you also must understand that from 0.40 to 0.49, it's a moderate positive correlation. Then if it's from 0.20 and to 0.39, that's a weak positive correlation. Then it's from 0.01 to 0.19, it's a very weak correlation. Then now when R is equal to 0, there is no correlation. Why am I reading these values? Because I want you to understand this. I'm saying them loud right now so that you can understand that you must be able to describe a correlation, to explain based on the value of R which you have. So if your R is equal to 0.8 or it's 0.8 exactly, or it's maybe 0.81, you must understand that that's a very positive correlation. You must write that down. It's always 2 marks. So beware of those things. I'll try to attach this table so that you can also have it. Okay. Then as we did also from positive, from 1 to 0. Now we start from -0.19 to -0.01. Then that's when we have very weak negative correlation. So it's so essential to understand that descriptive of the correlation. Now, great. Now, the other terminology which I want us to highlight is that we have what you call a scatter plot. So under statistics, we have what we call the scatter plot, which is obtained when a bivariate data is plotted on a graph by means of the XY plane. So we are saying that when we plot the bivariate data. What is a bivariate data? We say that it is the data that involves the study of variables at the same time, Okay, so now having that in mind, now we can be able to plot or to draw the graph, which is called the scatter plot. Okay. Now, if now we have a positive, let me write it here. So if we have a positive correlation, how will your scatter plot look like? So a scatter plot will look like this, okay? So a scatter plot will look like this. It will be, we say that a scatter plot is drawn on the XY plane, okay? We know that this is our X, this is our Y. If it has a positive correlation, which means it's scattered, so it can be like this. Then now we can actually see that maybe we have one here, a 1 dot here. So we can actually see that this is our outlier. So when we are having a scatter plot, we have an outlier at a number which is far from what we have. So for instance, you see that these numbers, they are close to each other, but this one is far, it's not even close to any number. That is what we call a outlier. And also look at something, this is increasing. So when you are seeing, when you are plotting our functions, when we're doing functions, we say that when we have a positive gradient, it's an increasing function. So we can actually say that a positive correlation, it is increasing, it has a positive gradient. Now, which means that the negative correlation, it will be now in the opposite direction. Okay, so since this one was increasing like this, which means this one now will be decreasing like this, then maybe we have an outlier somewhere here. So this is still an outlier. Why is it an outlier? It is found far off from other numbers which we have, so that's why it is called an outlier. Okay, so that's why it's called an outlier, because it's found far from other numbers. All right. Now, moving forward from this, I want to understand that what is an outlier. So as I was saying, that an outlier is a point that does not fit. Okay, why are we saying that it doesn't fit? It doesn't fit on the line of best fit or the line of regression. So this is so important. So now the other concept, now when we look at that, now we have what we call the regression line. The regression line. So this regression line now, the regression line, which is also called the line of best fit, is this line now when we are now joining our points. For instance, this is the graph, then we have the points here, we have the points here, we have the points here. So this will be our line of best fit. You don't have to make sure that it's like a line graph, which is like in this fan. Since this point is here, this other 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 point is here. It doesn't, you have to draw like a line graph like this and stuff like that. No, the regression line is not like that. The regression line is now the line of best fit. You draw your line so that all the points can be closer to that line. Okay, so that line is called the regression line. And how do we find the regression line? The regression line is a formula which is called y is equal to a plus bx. So this is our formula to calculate the regression line. What is b? B here is called the regression coefficient. Okay, so this is the regression coefficient. Then what is a? Our a, it is the constant value in the y-intercept. Okay, so this is the constant value in the y-intercept. Great. Now from there, so how do we plot this graph of a line of regression? So as I was saying that, for instance, we have our x line here, then we have our positive correlation like this. So we can actually draw the line of regression like this. You see, this is our line of regression. You can actually see that it's so close to the points. So if maybe we're having a point which is here alone, so this is now what we call our outlier, because it's not fitting to the line of best fit. So what is also important is, how do you get the value of r? How do you get the value of r? Okay, so what is important is that you must be able to calculate the value of r. What is the value of r? R is the correlation coefficient. And also this formula y is equal to a plus bx, which is our regression formula, or the regression line formula. These points of a and b are found on your calculator, which is a Casio. So how do we find the values of r and a? So what is important, I'll just say it. So what is important is that you must be able to press your calculator properly. Okay, so when you're pressing your calculator, you must always know that you can press mode. Oh, let me just highlight this again. So statistics, you do everything on your calculator. All the calculations on statistics are done on the calculator. You just have to be able to use our calculator. So I'll also attach the document for that part for the calculator, but just to go through it. So on that part, you must understand that you must press mode, and then you press 2, then you choose a plus bx. Then by pressing 2 now, what is going to appear first? It's going to appear that you must enter your x values. So what do we know that? We know that maybe we are given this, let's just draw this first. Okay, This is our X, this is our Y. So after you press mod, then you press 2, then now you choose A plus BX on your calculator, which is a Casio. Then now the next thing, you must enter your X values. After you're done entering your X values, you also enter your Y values also. After you press enter, then you press your AC button. Then after you press your AC button, then now you just have to press shift, then you press 151, then you'll be able to get your value of A. Then you press also shift 152, then you also get the value of B. So you must be able to follow the commands which I was talking about. Okay, so what is important in statistics is to be able to use your calculator. Okay, so that was my overview which I had for you guys for my grade 12 work. Now let's look at the exam paper which we have here so that we can apply what we were talking about. So great. So this is the question paper which we have. So on our question paper, we can see on the screen that we are looking at paper 2 2021 November. So what we are seeing here is that on question 1, on question 1, on question 1, on question 1. So on question 1, a bakery kept a record of number of loaves of bread as tuck shop ordered daily over the last 18 days. The information is shown in the table below. So this information was shown in the table below. So you can see that we have 10, 11, 13, 24, 14, 14, 15, 16, 18, and all those numbers which we have there. So let me highlight again something which is important. They are saying on the question that a bakery kept a record of number of loaves of bread a tuck shop ordered daily over the last 18 days. So in other words, the data which we have here is showing the number of breads which were ordered by the tuck shop in those 18 days. So we must now calculate the mean number of loaves of bread ordered daily. So what do you do in order for you to calculate the mean? The mean is the average of all the 18 days. So there are two ways in which you do this. The first thing is that you use your calculator. That's the first thing which I'll advise you. Use your calculator so that you can get. So you press your calculator so that you can get the values. Okay. So when you press your calculator there, what do you do by pressing your calculator? You press your mod, you press your number 2. Then after that, you can now put your data. You put your X, you put your Y values. Then after that, how do you look for mean? The mean is illustrated by this. Let me just do this. Okay, so 1.1. How will the mean be like? So the mean will be looking like this on your calculator, X like this, which is equal to. Then you get your answer to be 22. This is the mean. You use your calculator to get that mean. How do you get the mean? By following those prompts which I said earlier, that you press your mode button, then you press where you can see that it's talking about, you press your mode, you press your number 2, then after that you put your X values, you put your all the X values so that it can calculate for you. Then now this X naught is representing the mean. Or else you can add all the values. You can add 10 plus 11 plus 13 plus 14 plus 14 plus 15 plus 16, all the values which you have, and when you add them, they must give you 396. Okay, then you divide by 18 because we want the mean. The mean is the same as the average, so we want the average of everything. So the average of everything will be the total of all the loaves which were ordered daily in a tuck shop divided by the total number of days. Then after that, you're still gonna get the same 22. On 1.2 now, they are saying, on 1.2, the question says that the standard deviation, you can actually see it's 1 mark. So now on 1.1.2, sorry. So on 1.1.2, they want the standard deviation. So again, you go to your calculator, then you press your shift mode, then you press and you look for this sign. This sign is representing what we call the standard deviation of the data. So we can actually see that when we press our calculator, it's giving us 10,1707, which is this approximate to the nearest decimal. 2 decimal places is 10, 32,17. Okay, so that's our standard deviation. 1.1.3, the number of days on which the number of loaves of bread ordered was more than the standard deviation above the mean. So above the mean. So what is the mean? The mean is illustrated by this. Then you add your standard deviation, okay, so that you can actually see how many days on which the number of loaves of bread ordered was more than the standard deviation and also the mean. So in other words, they're saying that add the standard deviation and the mean, then the total will be able to assist you to look at how many days were it above the number of the mean and also for the standard deviation. So what was our mean? Our mean was 22 plus 10,17. So which is approximately 32 sorry, 17. Okay, great. Now let's look at the data which we have. Now what values do we have which are above that 32,17? So what values do we have which are above that 32,17? Okay, so we can see that we have one which is 35. We also have another 35, 2, 37, 3, 44, 41, 5. So how many days were there? It's 5 days which were above the mean and the standard deviation. Great. The next question says, the tuck shop owner was not able to sell all the loaves of bread delivered daily. He calculated the mean number of loaves sold over 18 days to be 20. Calculate the number of loaves of bread which were not sold over the 18 days. Okay. So what is important here is to understand one thing. Okay. So initially we say that the total which were ordered initially when we were calculating on 1.4, when we add all the number, we got that it was 22 times 18, which is equal to 396. What is 22? 22 is this mean which we have here. Then we multiply by here so that we can get this 396. So now they are saying that now for 20 days, for 20, that will be the mean. So now we must also calculate this. So we must say 20 times 18. Then 20 times 18 is 360, which were sold. Okay. This was the one which was sold. This one was the one which were ordered. So now, what are the total of not sold? Total of not sold. So now we are just subtracting is equal to 396 minus 360, which is the same as 0, then 36. So the 36 loaves of bread were not sold, as you can see. So what did we highlight? That we highlighted few things which were so crucial and so important. So we say that what did we do? We multiplied the mean which we got in number 1.1.1 and we multiplied it by 18 days. Then we got 396. These are the number of loaves which were ordered. Then now we are saying that the mean after they have been sold, it was 20. So we multiplied 20 by the number of days, which was 18, so that you can get the mean. So that you can get the number of loaves which were sold, which was 360. So how many were not sold? So the ones which were ordered minus the one which were sold, then we got our 36. Now great. Now moving on to the next question. It's saying that one of the two box and mixer diagrams shown drawn below represents the data given in the table above. Okay. Now 1.3.1. By now, you must be able to draw your box and whisk diagram. This is the mean value. This is the maximum value. We also know that we have this value. We have the median. We have this Q1 interquartile, the first quantile, and the 3/4 quartile. So you must be able to draw your mean, your box and whisk diagram. So now, 1.31. Which one of the two box and whisk diagrams drawn above correctly represents the data? Which one of these two represents the correct one? Of course, it's going to be option B, as you can see. Option B. Let me just say graph B. It's going to be graph B. Why is it graph B? On graph B, you can see here that any of the following range. So you can actually see that the median here is 18,5. So if you calculate here, you can actually see the median of this total number. So how do you find it? these numbers are already arranged in ascending order, so it's going to be 1 2 3 4 5. So these two here, between these two, 1 2 3 4 5 6 7 8. Then we also have 1 2 3 4 5 6 7 8 9. So we can add these two, 18 plus 19, then we divide by 2, then we can actually get the median number, which is 18,5, of which here the median number, which is Q2, is 30, which is totally wrong. So we are saying it's graph bin because the median is equal to 18,5. So in grade 12, they won't ask you to calculate the median. They'll ask you maybe just for you to get marks, but they usually don't ask you to get the median. Why? Is because they will ask you this indirectly, like the way they asked you this time around. So let's look at 1.3.2. So now they say describe the skewness of the data. You can actually see that this is the data is skewed to the right. You can see that to the left, sorry. So you can actually say that it is a positively skewed, or you can say it's skewed to the right. You can see that this is big when you're going to the right. So you can say that it is skewed to the right. Then you get your marks. Or you can say that it is, or you can say that the data is positively skewed. So we're saying that our data is positively skewed, or it is skewed to the right. Why? We can see that from Q2 to Q3, it's so wide going to the right. If it was this graph A, which means it was skewed to the left, or it was negatively skewed. Okay, then that was our question 1. Then our question 2, which is going to be done fast as well, which is the last question of the day, which will be talking about the grade 12 stuff. Grade 12. So on question 2, it's saying, let me read. A farm stall sells milk in 5 liters container to the local community. The price varies according to the availability of milk at the farm stall. The price of milk in rands per 5 millimeter container and the number of 5 liter containers of milk sold are recorded in the table. So you can actually see that this is our X, this is our high Y. So the moment you see this, you use your calculator, you press your mod, then after that you choose option number 2. Then after that, you insert your X values, you insert your Y values before you do anything. Now they say that on the graph which is provided below, plot your scatter plot graph. Let me just try to plot it first. Okay, right. So definitely on the graph, your graph must be beautiful, it must be neat, because you are given a nice graph. So let me just do a small range. On the X, you will see that they are starting from 26 going upwards. Then on the Y, they are starting from 26 as well. So you can actually see that's 0. Then we can actually, maybe we can actually start from 20. That was what we have on our graph book. Okay, so it was 20, 25, 30, 35, 40, 45. Okay, they're actually ending at 40. Okay, then you can put 45 as well. Then we have our 25, 30, 35, 40, and 45 as well. Okay, great. So why am I starting at 40 and 20 here is because this is the graph book which we were given that part. But when you're plotting a graph without being given a graph, a paper which you're supposed to use, your graph must start from 0 always. But since we are using our graph paper now, we can use this. So we can see that we have the first point, which is 26 is to 48. Okay, so actually we are going to 50. This is Y, this is X. So we have the first point, which is 26, 48. Okay, someone is going to ask me, where am I going to get this? 26 is in the X, then 48 is on the Y. So that is what is important to understand, that 26 here and this 48. Okay, so 26 is somewhere here, then 48 is somewhere there. So there will be somewhere here, we have a point there. Then after that, we have 32 to 30. 32 is somewhere here, 30 somewhere here. So it should be somewhere here. Then we also have 36 to 26. 36 is somewhere here. Then 26 is somewhere here. So it will be somewhere here. Then we have 28 to 44. 28 somewhere here. 44, sorry, 28 somewhere here. Then 44 is somewhere here. Okay. Then we have 40, 23, 40. Then 23 is somewhere here. So yeah, somewhere there. Then we also have 33, 32. 33 somewhere here, 32 somewhere here. Then there's 32 somewhere here. Then we also have 29 is to 39. 29 is somewhere here. 39 is somewhere here. Then we also have 34 somewhere here. Then 29 somewhere here as well. Then we have 27 is to 42. 27 somewhere here and put it somewhere there. Then we have 30 is to 33. Still somewhere here. Okay, put it somewhere here. So this is my ugly scatter plot graph. Why? It's because I don't have like the correct axis, but in the exam you'll be given the right axis to use. So that will be your scatter plot. Now determine the equation of the least squares regression line of the data. So we say that we will use our calculator to get the values of A. So when you use your calculator of you know that this is A plus BX. Okay, this is 2.2. So when I used my calculator, my A here, which I have, it's equal to, let me just write it here. The A, when I'm using my calculator, let me just use it. So it's gonna be 90,478. What is my B value? My B value it's negative 1,77. So therefore the equation will be y equal to 90,478 minus 1,77 x. So this is the line of best fit. This is the equation for the line of best fit. Then you get your marks. Then 2.3. Okay, now if the farmer sells a 5-liter container of milk for 38 rand, predict the number of 5-liter container milk he will sell. So actually now we are just predicting. So we can actually say that y is equal to 90,478. So we say that on 38, so we just substitute there, because we can actually see that on the x is representing the price of milk. So since we are given the price of milk, we can actually predict the number of 5-liter containers which we have here. So we can just substitute the 38 rand on the value on the equation of the line of best fit. Then we use our calculator. Then when I use my calculator, I get 23,07. Okay, now 2.4. Refer to the correlation between the price of 5-liter container of milk and the number of 5-liter containers and comment on the accuracy of your answer to the question 2.3. So as I was saying initially, that we must be able to explain or to describe the correlation coefficient, which is illustrated by R. So when you use your calculator, it's going to be negative 0.94. And how do you describe negative 0.14? We say that this value indicates a strong relationship between the cost and now. So now you can just use the simple words which you said, or you can write it and say that the value of R, since it's negative, it indicates a strong relationship between the cost per 5-liter and the number of units which were sold. So, or you can say that there is a good chance of the prediction being accurate. So you can say one of those two, or you can just say that it's a very strong or very negative. We see according to that table, it's a very strong negative correlation. But now you must now use that very strong negative correlation and apply it here when you are having the concept, or when you are applying according to the question which you are given. According to the question which you are given. So that is that, and that is all I have for you guys for today. I hope you enjoyed the session. Please, if you have a question, just ask, or if you want us to have more questions on this topic, please do ask and tell us on the comment section. So till we meet again, have a blessed day and continue preparing for your exams as well.